Okay. Okay. Now, good morning, everybody, to the second lecture, EEE201. This is the topic I'm going to discuss today is a basic electrical circuit parameters. Uh, Under this topic, what we are going to see all the basic elements of electrical system. As I told you earlier, there are three basic elements in electrical system, and those are resistor, inductor, and capacitor. Actually, this lecture is a review class of your HSC physics class, what you already studied, the different type of basic what do you call that parameters in electrical system. So the thing is, I told you until the midterm, we all will deal with the resistor element, the inductor and capacitor, along with the magnetic circuit will be discussed after the midterm. So resistor plays a very important role, and this is a linear device which is used for almost all the circuit theory in DC. So resistor is the thing we are going to start first. So today we are going to talk about this resistor as the system and signal. System and signals, if you go with that, the resistance is a system and the signals are like, you have studied in physics, the current, voltage, power, these are all signals, and resistor, inductor, capacitor, these are all systems. These are tangible element, and those are non-tangible parameters. So signals and systems, among these we are going to discuss today these signals: current signal, uh, voltage signal, power. These are the things we are going to talk today, as well as the system resistor we are going to talk today. These are our discussion point, uh, and you see most of the thing you have started in your physics class. So let us go with the next slide. If you go, then in the next slide you can see uh, basically the basic thing we are going to see here, the signal. So electrical signal is first one we can think about current. What is current? It's nothing new to you. You already know that current is nothing but the free electron movement through the conductor. So this electron is flowing through the conductor, and the amount of free electrons flowing through the conductor is a more or less. Based on that, the current will be more or less. So if you see that a conductor is like this, a conductor is something like a box I can write, then what you have started from your physics, that I is the current symbol flowing through the conductor. Maybe we can say this is there's a 5 ampere current is flowing through the conductor. So you all know that the A is the unit for the current, I is the symbol of the current, and 5 is the amount. So we can say 5 ampere current flow, 10 ampere current flow. These are the symbols way to represent for the current, as well as the symbol and the unit are shown in this way. This is all about the current, and this current I and A, all these things you have. Now, the basic understanding of the electrical current, if we go for it, then we can see the basic understanding. If you go, then in the slide, I think you have already gone through that, and this is giving you a clear understanding of the current flow. So if you go with this, a battery is connected with a bulb. So the current is flowing from the positive terminal to the negative terminal. Electron is flowing opposite from negative to positive, but conventional current direction is positive to negative. I think that's all you know. Now, what is this current is nothing but, if I say that what is 1 ampere current, 5 ampere current I have written there, but it's a definition of 1 ampere current is what? 1 ampere current definition is, if this number of electrons drift at a velocity in 1 second, then it is called 1 ampere. That means this number of electrons, 6 into 2.42 into 10 to the power 18 electrons, actually carries the charge, which is 1 coulomb charge. So it means 1 ampere current, actually defined as 1 coulomb charge, flows for 1 second. That is 1 ampere. Now, if I say this is 5 ampere, if I say this is a 5 coulomb charge, not 1 ampere, this is 5 coulomb. If we say that thing is a, okay, 5 coulomb charge, and then it will be 5 ampere, not 1 ampere. The 5 ampere, the 5 coulomb charge per second, 1 ampere. Now, if I say there's a 5 coulomb charge per 2 second, not 1 second, then it will not be 5 ampere, it will be 5 at 2.5 ampere, because it's a 5 by 2, 2.5 ampere. Like that way, we can say that if we say that it is defined as a symbol I ampere current, and then you can say this is a coulomb, a q coulomb charge, qc coulomb charge, 2 seconds, you say t seconds. So we can say that I ampere current is flowing, means q coulomb charge per t second. Then what will be I? I will be like that, q by t, because last time we saw 1 ampere is 1 coulomb per 1 second, and then I show you 5 coulomb per 2 second gives you 2.5 ampere. So in general, we can write q coulomb charge per t second gives you the I ampere. And that is the definition of current. We can write I equal to q by t. If we follow the same thing, we can write here that nothing but the current definition here we got I equal to q over t. This is what the current equation we can note. Now, if we go back to the voltage signal next, the voltage signal you are also very much familiar. It is known as electromotive force, EMF, or it is also called potential difference, which is described as the pressure or force that causes the electrons flow in a conductor. So if you apply the pressure between the two terminal, then a flow, like it is, if you can think about this thing, like look at it. If you think like this, I'm taking another color. Okay, if you think like this, a tube like that, so, and this is having some, this is having some water into it. Then if you apply the pressure here, apply the pressure here, and this is P1, P2 pressure. So if you have a pressure difference between P1 and P2, then what will happen then? The thing happened then is a water will flow from this to that. This is the way the water is going to flow. That means the pressure difference means the water should flow. You can think the water is electron, and P1, P2 is voltage, pressure, potential difference. So this is P1 is a E1 and P2 is a E2. The pressure difference means the voltage difference. If there's voltage difference, the current will flow, electron will flow. As a pressure difference, current is flowing. And if you go with the same direction, if it is less than that, this is P2 is more than P1, like that, then current will flow in this direction. So water will flow in the opposite direction. So which way the pressure is higher, it flow from higher pressure to lower pressure. Like that, in the potential difference also same. the conductor is here, the conductor, the current is flowing through that. If the potential difference E1 and E2, if you think there's connected to a battery is like that, you can imagine. So that potential plus minus, this is plus minus potential difference. If E1 is higher than E2, is a 0 volt, and this is 5 volt battery. So this terminal is 5 volt, this terminal is 0 volt. So the difference is 5 volt here, 5 minus 0, 5 volt here, plus minus 5 volt. We can say this is the voltage difference across the terminal, which is the current will flow from the positive to negative. The current will flow from higher potential to lower potential, that is from the positive 5 to negative 0. So 5 to 0, positive 5 volt to 0, the current will flow. But if you change the polarity of the battery, this one is bigger, this is smaller, this is plus and this is minus, then it will flow in the opposite direction, like that. So like that, we can say that the current difference, potential difference, is just the difference of the voltage or potential across the conductor, that causes the current flow. Now, if the, for example, if we see that the pressure is equal, not greater, equal, if pressure is equal, then what will happen? If the pressure is equal, then there will be no water flow. There will be no water flow at all. The whole water will be stagnant. So because of P1 and P2 are equal, the voltages are equal, like that. If you connect two battery, 5 volt battery, one is this way, another one is this way. This is plus 5 volt, this is minus 5 volt. So 5 volt cancel out, 0 volt. So you are getting 5 volt here, you are getting 5 volt here. So the difference is what? 5 minus 5, it is 0 volt. There is no, so no current will flow through that. Okay. Okay. All right. So this is the way we are going to describe the voltage from the pressure of the water. And if you see these things now, yes, it is the thing, it is told here that the electron can flow through the conductor if there is a pressure difference in the between the conductor, I mean two terminals of the conductor. Okay, now what is the symbol for
Sir,
voltage? Yes, sir.
can you clarify that yeah, again for if the last part, the battery polarity change of
Mm-hmm.
how when we change the polarity of battery, how the current flows.
Oh, no,
Can you
no.
explain it
Listen.
bit
I got a
more?
point. You look at it carefully. Huh? If you go like this,
Yes, sir.
if you connect the battery like this,
Yes, sir.
this is plus and minus. It is higher power, 5 volt battery, like say. So the current will flow this way, right? This is plus and this is
Yes, sir.
minus, higher potential. Now, if you change the
Yes, sir.
battery other way around, that is this way. Sorry. If you connect it like this is plus minus 5 volt, then current will flow in which direction? Now it will be flowing in opposite direction, right?
Yes, sir.
Yeah, it is flowing opposite direction, because this side is plus 5, this side is 0 volt, right? This is the negative side of the
Yes,
battery.
sir.
So difference is 5 volt, but in this direction, that's why current is flowing from higher potential to lower potential. I
Low
told,
potential.
yeah, I told that if there is another battery you connect here, which is this got
Yes, sir.
here, I'm sorry, this got here and this got here, then this is negative positive and this is 5 volt. Then what happened? This is positive 5 volt here, this is plus 5 volt here. Okay, 5 volt, and this is another plus 5 volt here, this is plus 5 volt here. Both sides of the conductor are plus 5, right?
Yes, sir.
It's not 0 now, this is 5. Do you
Yes, sir.
understand it? Just a
Yes,
minute.
sir.
Okay, now if it is 5, both sides are same, right? 5
Yes,
volt,
sir. There
5
is no
volt,
potential difference.
no potential difference. What will be the current flow? Hey,
No
Doc,
current flow
no
will be
current flow.
happen.
That's what I told. Actually, zero current flow will be there, because
Yes, sir.
it is the same potential difference. That's what pressure same means no water flow, right? So
Yes, sir.
if the voltage is same, there will be no current flow. You clear now?
Yes, sir. Thank you, sir.
Okay, good. Now all of us, if anybody got any other question, let me know. Do anybody got any question? Sorry, it's very much.
Sir,
Yeah, we have to go. Yeah, go ahead, because it is. I need to delete it like
sir,
this.
if
Go
I
ahead.
change the direction, if I
Uh,
change the direction, like
Direction of what?
instead of use the battery,
Hmm.
the charge, here
Hmm.
you showed that the second battery there is the positive charge uh, beside just left, and the negative charge is the right. But
Hmm.
I put the negative
Yeah,
charge
if you want to
at
change it
left.
other way around, right?
Yes, sir. Yes,
If
sir.
it is
Yes, sir.
other way around, then
So,
5 volt and 5 volt will be
so the
adding together. 10 volt.
yes, sir. Yes,
Yeah,
sir.
10 volt
I
means
just want
one.
to
Yeah,
note
one.
that.
Yeah, it's all right. One side will be positive 10, another side will be 0 volt. So the current will flow from
Zero,
positive. Yeah. That's good. Good question.
and that's combined.
Yeah,
That's
combined will
combined
be
all
10
the
volt. Yeah, 10 volt.
10
Two
volt.
battery you connect in series like that. You done it in
Yes,
the
yes.
normal case, right? That is the case. Okay, now let's come back to the
Thank you, sir.
point. Listen, we don't have already. We are having 3 minutes 30 seconds for first session to be finished. Please jump and connect it back as soon as this gone. I think you know that I told you earlier as well. Now let's come back to the.
Yes, sir.
Uh, 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 okay, just a minute. Okay. Okay, now let's come back. This is what I was talking about, the symbol for the voltage. This is the unit for the voltage. And then if based on this, if we can see that this is, as I told you, and it is the flow direction, current flow direction like this, as you understand. So I can, now everybody can understand this must be the positive, negative, and the potential may be E, and if potential positive here, negative here, because the current is flowing in this direction, we assume higher potential to lower potential. Maybe we can say E equal to let's say 10 volt or 12 volt battery. So if it is a 12 volt battery connected here, positive terminal here, negative terminal, current is flowing from this to that direction. Everybody can understand from this thing, but I'm just going to tell about the voltage definition. What is the definition of voltage? Okay, let's go and have a look of these things. I think you have seen from this. Okay, now look at it. The definition of 1 volt. Last time we saw definition of 1 ampere. This time we are going to see the definition of 1 volt. Now look at it very carefully. Definition of 1 volt means the potential difference of 1 volt or voltage 1 volt means, if you look at the picture here, there are two, uh, uh, what do you call that, charge point, 2 points here. So if I say the voltage difference between this point 1 to point 2 is 1 volt. 1 volt is the voltage difference between these 2 points. What does it mean? 1 volt between these 2 points. Of course, one is a positive, one is negative. In between this, the voltage is 12 volt, 5 volt. What does it mean? So 1 volt means what? From this point to that point. The 1 volt means to move 1 coulomb. 1 volt means to move 1 coulomb charge from this point. Let's say this is A and this is B point. So from A point to B point, to move 1 coulomb charge, if you need to do 1 joule of work done, that is called 1 voltage. That means 1 volt means to do to move 1 coulomb charge from this A point to B point, you need to exert, or you need to do 1 joule of work done. This is the meaning of 1 volt. That means 1 volt is giving you the amount of work done, 1 joule, for moving 1 coulomb of charge from point A to B. Now, if you need to move 1 coulomb charge from point A to B, you need 2 joule, not 1 joule, you need 2 joule. Then it will be 2 joule by Siemens, 1 Siemens, as a 2 volt. It is not 1 volt, it is 2 volt. Because to move 1 coulomb charge, you need to do 2 joule of work. That's why it is. Okay, so uh, you get my point. So this is
Yes,
what
sir.
the thing is. Now how you can go for it, then we can go. The problem we have to find is
Sir,
the given. Go ahead.
What does watt hours exactly mean?
Watt hour, right? That's what I'm going to tell you. First thing is watt hour is, you see the P equal to W by T, right?
Yes,
Right.
sir.
And W equal to P into T, right?
Yes, sir.
So this is P is watt. So this is what? Watt
Hour.
into hour. This is
Time
what hour
actually.
means, yeah. And this is what our energy. So in your electricity bill, it comes into kilowatt hour, right? Remember?
Yes, sir.
Yeah, that is the energy bill coming in your home. Watt hour means if divide by 1,000, it will be kilowatt hour, like that way. So 468 watt hour actually consumed by the headlight throughout the night. You driven your car from Cox's Bazar to Dhaka, it consumed, this is the amount of watt hour. That is the case. Now from here, this is given here. So what are the other things given? This is given. What is this? This is the voltage E, 12 volt, and 8 hours. What is this? This is given T, time, right? And this is
Yes,
given,
sir.
what is that? The W. W is a
W.
yeah, energy. That is work done. Energy is given there. That's it. Now W equal to PT. This got giving you the P. Hey, P equal to what? P equal to W by T,
W by
right?
T.
So W is what? 460.8 divided by T is your, T is your what is T? 8. So
8.
T is
8.
8. So you put 8. You got a calculator.
Yes, sir.
57.6.
50.85.
I'm sorry?
57.6.
57,
53.85 maybe.
no, 57.6
57.6
what?
7.6.
What is a unit?
watt.
Right. So this is the
Yeah,
answer.
57.6.
Yeah, this is the answer for the first question. That is, this P is that. Okay. This P is this thing. So P equal to 56.6 watt. Fine. It's done. Then A is done. Now go for B. B is, what is the current I? The B is, what is the current I? If you go B, the B is a current. If you want to find current equal to what? Now you look, relationship between current E is given, I you need to find, and you have another thing found P. So I, P and things. So what is the relationship between P and I and E? Hey, P equal to
P
what?
equals
I
to
E
equals
by
to
IE.
E
P
equal to
divided
I.
by E.
Okay, good. U equal to I into E. This relationship can give you the value of I. So I will be what then?
P by
4.8
E.
amperes.
4.8.
Right, good. That means already found, that is 57.6 divided by 12. What is the answer?
4.8, sir.
4.8. What is the unit?
Ampere.
Amperes.
Ampere. Remember, all of you remember, if you do not write the unit, 1 mark will be cut. And if you do not write 2 unit, 2 marks cut. Like that, if the full marks is 5 and you do not, 5 unit you do not write, you get 0. So careful about it. So unit is very important. Everybody must write the unit for it. This is the way you can find the answer to the problem, which is your, one is your 57.6, another one is your this value. Okay, I think all of you understood. Now I'm asking a very simple question. All of you look at this diagram. I think you have seen already this diagram. Can you, okay, all right, look at this. uh, in this diagram there are two picture. One is the carburetor is connected to the headlight number A, another one is connected to the B headlight in connection with the B. I'm going to ask the question to Faria Khan. Faria, can you open your mouth? Faria.
Yes, sir.
Yes, sir.
Yes, sir.
Can you see these two diagram? In both diagram, uh, there is a picture. Hey, look, there is a thing I can see here. A. What is this A? What is the name of the
Sir,
device?
it's emitter.
Ah, ammeter. Good. Ammeter measure.
Emitter.
Yeah, ammeter measure the temperature, right?
Sir, can you say it again? Sorry, what?
What ammeter does? Ammeter measure what? Have you used ammeter?
Sir, it's for the current.
Excellent. It measures the current. Yeah,
Yes, sir. It's to find out the value of current.
absolutely good. You have done it in the physics, but you did not do the practical.
Yes, sir.
That's why you may not answer the question. Now, my question is A and B, two ammeter connected to measure the current. Which connection is correct? A connection or B connection? Just measuring the current of the headlight.
Sir,
It is
current.
measured. Hey, come on. Tell me what is the. Hey,
Sir, current source can be connected in parallel.
That's you killed yourself. Okay,
Yes, sir.
listen. This ammeter measures the current of the headlight. It is connected in series with the headlight, and in this case, it is connected in parallel. So you say it is connected in parallel is the correct one, right?
Yes, sir.
Yes, sir. Like you, a lot of students actually connect it in this way in the lab and spoil our ammeter. And one by one ammeter are not working because this is the way you connect the ammeter to measure the current. Absolutely wrong.
Okay, sir.
Ammeter is connected in series to measure the current of the headlight.
Okay, sir.
And if you want to measure the voltage, then you have to connect the voltmeter. Remember, not forget it. The voltmeter should be connected. Is a voltmeter. This is a plus minus terminal. And this voltmeter is measuring the voltage across the headlight. Headlight voltage is what? That voltmeter should be connected in parallel. Remember, ammeter is connected in series, voltmeter is connected in parallel. So if you connect the voltmeter in series, it is wrong. It is not the correct thing. Voltmeter cannot be connected in series. I hope that everybody understand. Now,
Yes, sir.
yeah, the ammeter, you have measured the current. Okay, a sleeping partner, another duck. Farhan Tanjim Tonmoy. Fariha, can you please?
Yes, sir.
All of you, please shut your microphone off except Tanmoy. Yeah, Tanmoy, tell me,
Yes, sir.
what is the measurement value? What is, if you connect the ammeter at night to measure the current here, what will be the ammeter value in our case?
The one we just measured.
Yes, sir.
Yeah, like you want with. I don't remember the value.
Now look at it. Can you see the
Sir,
script?
4 point. Yeah, sir, 4.1, 4.8 ampere.
Good. So this is what the 4.8 ampere the ammeter can measure. And what will be the voltage voltmeter can measure? Can you tell me? Read the question.
Sir, it's gonna be 12 volt, right?
Because you look at it. Last line, assume the battery voltage remains constant throughout the whole discharge period. So yeah, that is giving you the voltage across this, which is the 12 volt actually coming, because the 12 volt is coming from this to that, from this to that. So ultimately the battery voltage is going across this. A little bit drop can be across the ammeter, which is very much negligible. So it is assumed same because 12 volt is coming there. Good. So if this is the way we can measure the voltage in ammeter, then we can get this value from the car if you drive. When you drive the car, and that time if you measure, you could get it. And now the time is over. I'm not going to go for the course, but I'm just going to show you one thing. All of you just look at it. This is the question, last question here. I think all of you can see. This one, you have to solve the problem by yourself at home. and you can find a solution, or otherwise we can discuss. Yeah, you can discuss among yourself also in order to find it. I think that's all for today. And your homework at home, you have to just, please 1 second, at home you have to go for solving the problems. This thing, as I show you, this one, then come with this. Sorry, where is that gone? Okay, not downloaded. Okay, there is another. Oh, I'm sorry. Okay. Okay, I'm going to show you this one. Then you can see this problem. This is the second problem you have to solve as well. And third problem is also here. There is third problem and then another one. These 4 problems we are going to solve in the next class. So all of you, please, my request, all of you, please go through these 4 problems and try to solve the problems also by yourself. If you have any question, any problems, you please let me know. Then I will try to solve the problem for you. It will be easier for you to understand when I solve the problems in the class, in the next class. So all of you, please try to solve it by yourself. At least you try to go, and when I solve it, it will be very easy. And last semesters I saw students, those who had gone through these things before coming to the class, it becomes very simple for them. All right, I think that's the end of the class today. And you, yeah, go ahead. Bit faster.
The last question you give us, do we have to submit it? Yeah, that
Which one? Which one? This one? Oh no, I'm sorry. You're talking about this one. This one. This one.
This handwritten one, yes, sir.
Yeah, no. You don't need it. This is just a practice at home. You don't need to do anything. Just a practice. It's a simple problem. You just don't worry about it. You don't need to do anything. Just take it easy. All what you need to understand things, that is the most important thing during this corona pandemic size. So and I'm going to announce the thing when is going to be the exam and all these things. Now I assume that everybody understood the lecture today. Anybody got any question, please ask me. And those who are having class, next class, you can drop and go. And those who are no having class, if you have any question, you can ask me now, because the next class before 15 minutes, maybe you cannot come because you have another class. So if some of you have no class now, maybe 152, please, you can discuss. If no problem, then I think we can go ahead, because I have another class after this. So I have to join that class. I think that should be fine if you don't have any class. Do you anybody got any question, or it's all right? Anybody can.
Sir,
go.
Sir, in the last slide, we saw that there is an ammeter in the connected with the
ammeter.
So there is no there is no resistance.
You're talking about here in this case.
Yes, sir.
Yeah, the resistance is this. This is the resistance. The headlight.
The headlight is the resistance.
Yes, sir. The power is dissipating through the resistance, because if you touch the headlight, it's very hot, right?
Yes, sir.
So I square R is the power, and this power is actually dissipating. I told you that dissipating means it's a wasting through the in terms of heat. So when you're on the light, it is become hot, because I square R loss, the loss in the heat, light, all combined together. Energy conservation rule, you can see that. So it is the resistance. Yep.
This is the first. In the first case, there is a no loss of voltage. So how it is possible? If there is resistance, so there is some loss of voltage.
What do you mean by loss of voltage? The voltage is across the resistance. Look at it. The whole voltage is coming. The battery is here. Look at it. Okay, now look. This is the resistance, and this is a 12-volt battery connected. So if I ask you what is the voltage across the resistance, you tell me what?
12 volt.
12 volt. There's a battery full across. So the whole battery 12 volt is coming across the light. Oh, I told you a little bit drop here, little bit loss. That one negligible. For the time being, you don't think about it. You are very, very starting course. That is when you go further in the next couple of lectures later, you can see about those things. But don't think like that. Now take it easy. This is the scenario.
Yes,
You're all right. So take it in that way.
yes,
Should be
sir.
fine. I think that should be great question. Any other? Yeah. Any other question? Yep.
No, sir.
No.
Thank you.
Sir, the recording of this class, will it be on books?
It will be on the books. Yeah. But yeah, that's right. Any problem? But I'm just asking you. Who asked me this question? Akib. Okay. Whoever asked me the question. Now listen. I'm just telling you. If it is given, do you just asking you? These are personal things. Is it okay with you if I don't, let's say I don't put it into the books? Is it okay with you, or you think no, sir? We have to go through it again. What do you think?
Sir, it's very helpful if we yeah no, if we can
put
watch it again.
Of course, it will be uploaded there. But I'm just asking you, are you still unclear? That is what I want to know actually. That means you are still not clear maybe. That's what I'm talking.
Sir,
Okay.
it's not that. It's actually like I had a class at 8 and I'm still sleepy and like
Okay,
something
I
might
got it.
have yeah.
Oh, some of you got late. Okay, no problem. Definitely every lecture should be uploaded now. Should be fine. Thank you very much. All the lectures, what I'm going through, it will be uploaded and you can go through the lectures. I think that should be great. No problem. I wish it's all right. Thank you very much.
Thank you, sir.
Thank you, sir.
Assalamu alaikum, sir.
Alaikum salam. Alaikum salam.
Assalamu alaikum, sir.
Alaikum salam.
Assalamu alaikum.
Alaikum salam.